Okay, hello everyone. So today we're going to talk about electrolysis. So what you're going to learn in electrolysis, I think you guys may have an idea of what electrolysis is from your lower sec of sec 1 and sec 2. So we're going to talk about what actually happens in this chapter here. Okay, so let me just jump right straight in. Okay, when you look at an electrolysis experiment, so when you look at this experiment, there are a few things to take note of. So the first thing you want to pay attention to is actually these two black things here. So this is what we call the electrodes. Okay, so the electrodes are connected to the battery and you have two of them. Okay, so one is called the cathode and one is called the anode. So for this specific experiment, you'll notice that whatever that is called connected to the positive terminal will be the positive electrode, and whatever electrode that's connected to the negative terminal will be the negative electrode. Okay, in this case, what I need you to remember is that cathode will always be responsible for reduction. Okay, and anode will always be responsible for oxidation. So reduction reactions always takes place at the cathode and oxidation will take place at the anode. The next thing here is actually the liquid that is inside this experiment. So it will actually be the electrolyte. So the electrolyte will be over here. So the electrolyte cannot be covalent, alright? It must be an ionic compound that is aqueous or molten. So the reason why it needs to be aqueous or molten is because it needs to be able to conduct electricity. Okay, so it will be able to conduct electricity. Okay, so moving on from here, let's talk about what happens during your electrolysis. So what actually happens during electrolysis, this is a very, very important point, please focus on this, is that ions, okay, will go to the electrodes to become atoms or molecules. So to give you an example, if let's say I have Na plus will become Na, right? If I have H plus will become its molecule of H2, right? And if let's say you have Cl minus, you'll become Cl2. Okay, so this is what's happening. The ions will become atoms or molecules. So what you need to know here is that anions will go to the anode to get oxidized. Cathodes will go to the cations will go to the cathode to get reduced. Okay, so in this case, if you ever forget, anions are negative negative ions, and cations will be positive ions. Okay, right. So in this case, if you're wondering how does this ever happen, is because the anode will be positively charged and the cathode will be negatively charged. Okay, and you realize that opposite charges will attract. Okay, so you have no questions. Let me just move on to show you what actually happens in the first type of reaction. Okay, so we're going to talk about molten substances. So in molten substances, it's very easy. Why? Because there's only one type of positive and negative ions. So if you jump into this example here, let's take a look at NaBr. You have Na plus and you have Br minus. So before even looking at the rest of this question, we know that Na plus, okay, will become Na eventually. And we know that Br minus will become Br2 eventually. So to balance this, okay, let's take a look at Na plus and Na. You'll realize that the charge does not balance out. So because of that, you have to add electrons to the left-hand side. For Br, okay, you got to add 2 to the Br minus, and because the charges are not balanced, you balance them with 2 electrons over here. Okay, so if you can understand, this is exactly what's happening. So your sodium, right, ion, your Na plus, will actually become your Na sodium metal, right? So in its molten state. And your Br minus ions will become your bromine, right? So it'll be a liquid state in this case. Okay, so if you take a look here, okay, this is your reaction. Na plus electrons will give me Na, right? So this is actually a reduction reaction, right? If you still recall why, because you have gained electrons. Okay, on the other hand, okay, if you take note at this equation, you see that I have written minus 2 electrons. So this isn't actually correct, but just to show you that this is the loss, right, of electrons. But by right, if you bring it over, then how would your equation look like? Okay, it will look something like this. 2Br minus to become Br2 plus 2E minus. This is how it actually looks like. So in chemical equations, we never write that we subtract something. Okay, but this is just to show there's a loss of electrons, which actually represents your reduction. I mean your oxidation, right? Because when you lose electrons, it's an oxidation. Okay, so you can see how there is two parts of it. One is oxidation, one will be reduction. Okay, so if you're okay with this, let me just show you which questions you need to do. Okay, so you'll be on page 16 over here and page 17. Okay, so you can try this, page 16 and page 17. Okay, now that you have done this, let me show you what's next. Okay, so let's go back to the notes. Okay, what happens now if, let's say, I'm trying to do electrolysis for something that's aqueous? So what aqueous actually means for you, it means that the substance is dissolved in water. So this complicates things a little bit. Why? Because water dissociates into H plus and OH minus. Okay, so because of that, there are multiple ions to consider. Okay, so what you need to do here is that you need to make a choice between what gets discharged, right, at the electrode. Okay, so over here, right, there's actually a multiple reasons. There's like concentration, there's a reactivity series and all that. But I'm going to skip all that. I'm going to give you guys a shortcut for you guys to be able to do the question first. So once you guys have understood that, then I will run through the reasoning why. So when it comes to cations, okay, so this will be your positive ions. What you need to do, right, is to actually choose the cation that produces the most stable product. Okay, and then for your anions, you will choose, right, the anion that is highest in concentration. Okay, except for NO3 minus, SO4 2 minus, CO3 2 minus, and NH4 plus. Okay, so apart from these four, alright, you can choose your anions that is highest in concentration. Okay, so once you have gotten this, I want you guys to try a question first. Okay, or maybe I can show you an example before you guys go ahead. Okay, so the reasoning behind it I'll explain once you guys have understood how to do certain questions. Okay, so let's take a look at a very quick example here. Okay, just go down to this page here where you talk about concentrated NaCl. So when it comes to concentrated NaCl, it means that this is dissolved in water. You have your Na plus, Cl minus, H plus, and OH minus. So remember, between the positive ions, you have to choose the one that produces, right, the most stable product. So in this case, you'll realize that Na plus will produce Na and H plus will produce H2. And of course, H2 will be more stable, so I will actually choose H2 to undergo the reaction. Next, this is concentrated, so between the negative ions, I will choose my Cl minus. Okay, so you can see how my two equations would be one involving hydrogen and the other would involve the chlorine gas. Okay, so remember to shift the electrons. Okay, and if let's say this was done using diluted NaCl, right, then in this case, it will be your H plus and OH minus that will be discharged. Okay, right, so if all is good, I just want you to pay attention to the equation on the anode. This one you have to memorize. Just always remember that OH minus produces oxygen. All right, so if all is good, let me just show you guys which question to continue on. Okay, so I want you guys to continue on to page 18 over here. Okay, you guys can do page 18 and page 19. Okay, so if all is good, let me go back to the next part. Okay, so at this point in time, you can let the students try the question. Okay, and how I will show them is to actually continue on with more and more questions here, and they will be able to try and see what is the, to get them, have a hang of which ions to choose. Okay, so there'll be parts like copper, right? So just take note that actually in this place copper 2 plus will be discharged over your hydrogen, because copper is more unreactive. Okay, so once you have done up to this question on page 22, you can actually cut back up. Okay, then I'll show them the new thing about the special cases. Okay, so let me go back. Okay, so now, right, I'm going to go through a special case. So you can come back to page 13 over here. Okay, so now I'm going to show you guys a special case. So what actually happens here, right, is when you use a metal that's placed into a metal salt, and you will realize that the electrolysis don't happen. Normal electrolysis don't happen. So what am I trying to tell you? So when your metal that you use and the salt that you use contains the exact same metal, something special will happen. Okay, so for example, if you use copper electrodes in copper 2 sulfate, right, something special will happen. Okay, so let me show you what actually happens here. Instead of normal electrolysis, there will be a transfer of mass from your anode to your cathode. Okay, so that means, right, your copper anode will actually dissolve over here. Okay, while your cathode, right, will actually discharge the copper 2 plus ions, and then copper will form at the cathode. Okay, so that means the cathode will increase in size. So one important point to take note of, your copper ions, right, are reduced, right, and the copper ions are constantly replaced due to the anode. Okay, so you can see this is the reason why it's being constantly replaced, right? So because of that, there will be no color change and concentration change. Okay, yeah, so with that, this is more or less the last part of teaching. You can let them try on some questions before you go on to the next part of the application. Okay, so let me show you guys which questions you guys can let them try. Okay, you can let them try this question over here. Okay, this is on page 24. Okay, so once they have done this, then you can go back to the notes. Okay, so now that you guys have done the questions, right, okay, let me show you guys what is the application of doing what we just did just now. Okay, so whatever we did just now, you can actually learn that the first application is electroplating. So if you pay attention to the battery here, okay, as electricity flows out here, okay, you'll realize what will happen is that this anode here, this is the anode, will dissolve. Okay, so the copper will travel along, all right, and it will actually coat the cup here. All right, so this guy is the cathode. Okay, so the cathode will increase in size because the copper will coat around the cup. Okay, and that is how it happens. Okay, so another application of that is to purify copper. So same thing, right? If you want to purify copper, you can attach the impure copper onto the anode. Right, so remember, in the anode it will dissolve. Okay, so as electricity flows, okay, you can see that your pure copper will travel along, right, and it will accumulate at the cathode. Okay, so what's left behind here, you can see, is the sludge. It will be all the impurities that won't participate in the reaction. Okay, so with that, that is all I have for you guys for today. Then you guys can go ahead and try the rest of the question, which is your page 25. Okay, so once you have done page 25, you can also try page 26. Okay, but these are the main questions over here. So 26, usually I only give the students if, let's say, they are very fast. If not, I tend to avoid that question. Okay, all right, if not, then that's all I have.